All right, boys and girls, welcome back to the drive-thru, a special Monday edition. Sponsored as always by the deli. Hungry? Stop by the deli. I don't know what I'm going to get today. It's a new week, and I'm excited for that because the deli starts over every Monday. All right, so this is question 25 from section 5.7, okay? And this is a probability question. The problem reads, ABCD is a parallelogram. If two of the following conclusions are selected at random, what is the probability that both of them are true? Well, just like you said, the first thing we should do is evaluate which one of these statements are true individually. So, in a parallelogram, are opposite sides congruent? So that one is true. In a parallelogram, do the diagonals bisect each other? That makes E the midpoint of what? Good. Both of the diagonals. Okay, so that's true. ADC is supplementary to DAB. Would you consider those to be consecutive angles? They're same side interior or consecutive in the parallelogram? True. This is the one that a lot of people often get wrong. I'm sure you were thinking on this question, like, well, one of these things has to be false. Okay? Here's what I'm telling you. When you draw a picture, if you draw a parallelogram, and that parallelogram happens to look like a rhombus, then you are going to draw the wrong conclusion. Does that diagonal bisect the angles? It does in a rhombus. So then what you want to do is draw something that's certainly not a rhombus. Can you see how that's certainly not a rhombus? Now look at the diagonal. If that thing was straight, okay, let's redo that one. All right, now, are you going to sit there and tell me that this angle is congruent to that angle? No way. Okay, so this one's false. So that's a good time to bring that back up. If you're on the test and you forget one of these gazillion facts that you're learning, just widmapoi. Just make sure you're drawing a very good picture. Don't mistake your picture for something else. Okay, all right, so now to the probability part of it, okay? We're picking two things. We're just going to make a list. All right? I'll show you two different ways to do this. One is the list method. So you can pick 1, 2, 1, 3, 1, 4. What would be the next organized set of lists I would make? 2, 3, and 2, 4, and then finally 3, 4. How many different ways could I select two of these things out of a hat? 6. How many of them are both true? Well, they're only going to be both true if they do not contain what? So that one's true, that one's true, and that one's true. So that's how you get the answer. Now, okay, here's the mathematical, statistical way to do it. And I hope that you all take statistics while you're here. You'd be crazy not to, okay? About 40% of American students that go to college have to take calculus. About 98% of them have to take statistics. But what's weird is all of our math sets you up so that you take calculus. It's really a bad way to do it. We should make sure every kid takes statistics. And that's more true now than it's ever been. Why? We have more data. We have more data than we've ever had. So it's really important that you know what to do with your data. Okay? All right. So what's the probability on our first draw that we picked a true answer? 1 out of 4? 3 out of 4, right? Now, when you're playing this simulation, you assume that you won the first one, because if you didn't successfully draw one, you would be done. I mean, that's how you kind of consider it. So, now, what's your probability that you select a true one on your second one? That's right. You need both of these things to happen, so we multiply, and gives you multiply. So what does that give you on the top of the denominator? Denominator. 6, and on the bottom, and that gives you the same answer. So that'd be another way you could do it. Okay?